To keep yourself updated, subscribe to Indigo Learn and click the bell icon.
Friends, in today's class, let us talk about one of the most discussed topic in your enterprise information system, that is flowchart. So at the end of the class, you will be able to understand what is flowchart and you will also be able to draw a flowchart on your own. But before we directly dive into the topic of flowchart, let us have a basic discussion about why we require a flowchart. So let's take one example first. Say that I have a friend of mine who is approximately 10-year-old by the name Abhi. So one day Abhi called me and he said, "Are you busy?" I said, "No, I'm not busy, tell." And he said, "Nobody's at his home, but he wanted to drink something." I said, "Why don't you drink Bonvita?" And he said, "I don't know how to prepare Bonvita." I said, "I'll help you. I'll help you." So I asked him to go to kitchen. So Abhi goes to his kitchen and I'm on the line and I'll tell him how to prepare Bonvita. So disclaimer first, nor Abhi is a cook nor am I. So I am going to tell what I know. So I said to Abhi, see, take 1 glass of milk, pour it into a vessel and boil it for 2 minutes. After 2 minutes, pour it back to your glass, put 2 spoons of Bonvita, 1 spoon of sugar, stir it well and here your Bonvita is ready. And I thought I explained him how to prepare 1 glass of Bonvita. But Abhi is like, "I heard what you said, but I did not understand. You are too quick and I can't follow." I said, okay, just be online and this time we will do it in a little different way. Rather than telling everything once, I will divide the steps. I will break the steps into one by one. So I will say, step number 1, take a glass of milk. Abhi says, "Okay, I have taken a glass of milk." Step number 2, pour it into a vessel, and Abhi says, "Okay, I have understood it, I have poured into a vessel." Step number 3, keep it on the gas and light your gas. He said, "Okay, he has done it." Step number 4 is wait for 2 minutes. So Abhi and I are online for 2 minutes and after 2 minutes I will say, "Okay, 2 minutes up." Step number 5, turn off the gas. This is very important. I will say step number 5, turn off the gas. Abhi says, "Okay." Step number 6, that is pour milk to a glass. It is there in the vessel now. Pour it back to a glass. Abhi says, "Okay." Step number 7, put 2 spoons of Bonvita and 1 spoon of sugar. Abhi says, "Okay." Step number 8, stir it well. Abhi is like, okay. And I said, "Yes, your Bonvita, now it is ready, you can drink it." So now, what is the difference between the previous explanation and the next explanation? Previous explanation was in a paragraph form, which Abhi couldn't understand, but the next one is a step-by-step procedure which even a kid of 10 years of age could understand this. So whenever I define a process in a step-by-step approach, I call it as algorithm. I call it as what? I call it as algorithm. Now I want to make it more attractive, more simple, so that Abhi can follow it. So rather than writing in a step-by-step order, I want to convert it into a flowchart. So flowchart is nothing but a diagrammatical representation of algorithm, or I might say flowchart is nothing but a pictorial representation of this algorithm. I repeat again, what is flowchart? Flowchart is I am defining all this step-by-step procedure in the form of a diagram, in the form of a picture or in the form of a chart. Hence we call it as flow chart. So in flow chart you actually understand how the process should flow from one step to another step. So if I have to explain same algorithm or same steps in the form of flow chart, how am I going to tell him? First I will say you need to start always the first step in any flow chart is start. That is, I am asking Abhi to first go into a kitchen, correct? So I will say start. So what is the second one? After he starts, I will say take a glass of milk, and all the other steps are the same. But how do I put it into a flow chart? How the shapes I am going to give? Because in flow chart, if you have seen before watching this class, you may have seen for some items there is a oval shape, there is a circle, there is a rectangle, there is a parallelogram. So different shapes are used for different processes. So we will take up one of the sums and we will understand what shape to use in what type of process. Initially I want to have you an understanding about why I am using flowchart. So again, to repeat, what is the algorithm? Algorithm is nothing but step-by-step representation of a particular process. What is a flowchart? Flowchart is nothing but pictorial representation of the algorithm. So in the next class, we will study about how to draw flowchart. But before that, we need to make couple of discussion. We need to understand some key terms when it comes to flowchart. One of the term what I want you to understand is the difference between constant and variable. What do you mean by constant and what do you mean by variable? If you look at the word meaning, you may say that constant is which is constant, variable is what is variable. So constant will not change, variable will always change. Let's take an example to understand this. Let us understand what is constant. Let us say that when you are in your first standard, if I had asked you what is the name of your mother, you would say your mother's name is whatever your name is. And if I asked you in 7th standard, what is the name of your mother, you will say the same answer what you told in the first standard. Will your answer change? It will not change. Even if I ask you now what is the name of your mother, you will say the same answer. Why? Because mother is constant. Mother will not change when you grow. Mother is same. But on the other hand, what is variable? Variable is something which keeps on changing. For example, had I asked you who is your best friend when you were in 7th standard, your answer would be something else. And if I asked you the same question when you were in 10th standard, who is your best friend, your answer is different. Answer will change when you are in 12th standard. And if I ask you now who is your best friend, answer is different. Exceptions, yes, it is there, but normally I am saying that best friend, the answer to the question who is your best friend keeps on changing each and every time. On the other hand, answer to the question who is your mother is always constant. So that is the fundamental difference between what is constant and what is variable. The value of constant will not change, but the value of variable can change. So this understanding will help us to solve the sums. Because in certain sums, initially they will say, assume x is equal to 0. Then they will say x is equal to 5. Now you shouldn't be confused. How can x be 0 as well as x be 5? That is because x is a variable. Initially, the value of x was 0. Afterwards, in the sum they told x is equal to 5. Is it possible? Possible. Why it is possible? It is possible because x is a variable. If x was constant, can you change the values? You cannot change the value. Just because x was variable, just like the definition of best friend, the values assigned to the particular variable can change. So this is the fundamental of flowchart that you need to understand before we start solving the sum. Now let us take one more illustration to understand flowchart better. Now this is out of my personal experience. One of the hardest question in my life is to answer an elderly person about how to do CA. Normally, whenever I used to travel by bus, the person sitting next to me used to ask, if he knows me, used to ask, what are you doing? If the moment I say CA, he would ask, how to do CA? Now, it is very, very difficult to tell him. If I tell him foundation, inter, articleship and your computer course and your soft skill training and final examination and all the other things, he'll be totally confused. So, what can I do? I can explain him step by step. So, I will say, first one has to clear his 12th standard. After clearing the 12th standard, what is the next step? Foundation. After clearing foundation, what else? It is inter. After clearing inter, what you can do? You can join for articleship. Now, articleship, can you immediately join and write your finals? No, you have to complete 3 years of articleship. After that, you write your CA finals. After clearing your CA finals, are you a chartered accountant? No, you have to apply for membership number. So, this is the step-by-step procedure about how to become a chartered accountant. So, this I call it as algorithm. Now, if I want to give a more clearer picture, rather than telling step by step, what will I do is I will draw a flow chart and I will help my friend to understand, or that elderly person who asked me that question to understand how to do a CA course. So, how am I going to put it? First, I will say start. What is the first step? Clear 12th standard. What is the next step? Clear foundation. What is the next step? Clear inter. So, till now, it is a simple process. I am not talking about the syllabus and the complexity of the examination. I am saying that there is no confusion in here. But after you clear inter, what is the next step? You join articleship. After you join for article shape, now can you immediately write examination? We discussed already, you cannot immediately write examination. So you have to wait for 3 years. Okay, you have to wait for 3 years. Only after 3 years is done, you can write your CA final examination. So there is a waiting process what needs to happen for 3 years. Now, if a student asks, can I do after completing 1 year of articleship? Answer is no, you cannot do that. You cannot write CA final right after 1 year of your articleship. You have to wait for 3 years. After that, you write your finals. Once you get the result, you apply for membership. Then you stop. Why do you stop? Because you already are a chartered accountant, there is nothing else you got to do. So what I want you to understand from this particular illustration is, always there is a start and there is always a stop. Start talks about start of the journey or starting of the process, and stop indicates end of the process. Because if there is no stop button, then this process will be running into infinite loop. Alright, so in every flow chart you will see start and stop, no matter what this flowchart is. So this is the one of the basic input which I wanted to give. About other shapes we will understand in the next step. Now let us talk about different shapes which is used in the flowchart. There are many shapes which is given in the material, but you don't have to understand and remember all the shapes. You mainly have to remember 4 shapes. These 4 shapes are very important in your examination. You may also come across other shapes, but importantly these 4 shapes. What are these? First one is, whenever you start or stop, you use an oval shape. So you use oval shape only when you start a process and you stop a process. Nowhere else you are using this particular shape. So are you clear with when do you use oval shape? When do you use it? When you start a process and when you stop a process. The next shape is rectangle. A rectangular box is used in 2 occasions mainly. One is whenever you are assigning a value. Whenever you are assigning a value, you use this rectangular shape. And whenever you are making a calculation, you are using a rectangular shape. Now what do you mean by assigning a value? If you are to say x is equal to 1. Now when you say x is equal to 1, you will put it in a rectangular box. If you want to say z is equal to 10, how will you tell? You will put it in a rectangular box and you will say z is equal to 10. Now you may say, what is this x, what is this z? We will all solve it when you are doing a problem. But first we need to understand which shape to use where. So whenever you are assigning a value for a variable, you will use this rectangular box. One more place where you will use this rectangular box is whenever you are doing a computation or calculation. Now what are the different types of computation or calculation? You may do addition, you may do subtraction, you may do multiplication, you may do division. All these different mathematical computation, whatever you do, whenever you are doing it, you use this particular rectangular shape. So we discussed when do you use oval shape, that is in start and stop process, and when do you use rectangular shape, that is either to assign a value or to do a mathematical function or to do a computation. So now let us talk about the next shape, that is parallelogram, and we will see how we can use this particular shape. This particular shape is used whenever I want input or output from a software. Let's take one simple example. Say I want to total any 2 numbers. So what is going to be my algorithm? Algorithm is step number 1. Input those 2 numbers. So I may say 2 numbers are x and y. So user can say x is equal to anything, y is equal to anything. So step number 1 is insert x, insert y. Step number 2, sum is equal to x plus y. Sum is equal to x plus y. Step number 3, output sum. So this is the 3-step process. What is the first step? That is to give the input into the system. I have to tell what is x, what is y. Next step is system will automatically calculate. I am not doing anything. Step number 3 is system is giving me the output. Now you tell me for these 3 steps, if I have to draw a flow chart, how it will look like. First thing is start. First thing is start. What is the next step? Input x and y. Input x and y. Now the user has to enter value into the system. So what shape am I going to use? Can I use oval shape? No, oval is only for start and stop. Can I use rectangular shape? No, it is only for computation and assigning the value. But here you are not assigning the value, you are inputting the value. correct? You are inserting the value into the system. So you are using a shape called as parallelogram. So it will say input x, comma y. Third step, that is computation. What shape should I use? System will use, or the system has to compute. So what shape can I use? I will use rectangular shape. So I will say sum is equal to x plus y. So is it done yet? No, I want to see what is the sum. I want to see what is the sum. So I will say print sum. I will say print sum. Print is nothing but an output call. I want to see what is the output. So I will say print sum. So this print sum will also be in parallelogram shape. So in this there is one input, that is input x and y in the parallelogram shape, and there is one output, that is print sum, that is also in a parallelogram shape. So is it done? No, there is one more step. What is the step? That is simple. I need to stop this. So start, enter x and y, computation, output, stop. So this is how simple flowchart is. So this is the basic discussion about flowchart. We have taken couple of examples. Now we will discuss one more shape. This is the important shape, that is diamond shape. So when do I use this particular diamond shape? I use this diamond shape whenever there is a decision making process. Whenever there is a decision making process, I will use this particular diamond shape. Let's take an example. Say there is a club in your place, or there is a pub in your city. Now the condition of that particular pub is only persons who are above 18 years can go into that pub. Now every time you walk in, they will ask you to produce your identity card, let us say your Aadhaar or your voter ID, whatever it is, where your date of birth is written. So whenever you give your date of birth, he will put that into a system, and the system will tell whether you are 18 plus or not. If you are not 18 plus, what will happen? He will send you back. If you are 18 plus, what will happen? He will send you inside. So here there is a decision making process which is done by the bouncer who is standing at the gate. What is the decision making? He has to decide whether you are 18 plus or not. So whenever there is a decision making process, we use diamond shape. Now let us look at the flow chart of this particular scenario. How will you start? You will start by writing start in a oval shape. What is the next step? The next step is input date of birth. So whenever you are saying input date of birth, which shape are you going to use? If there is an input, you are going to use a shape called as parallelogram. So second step is done. What is the next step? You need to compute what is the age. You need to compute what is the age. So how are you going to compute? So you will say the age is equal to current date minus date of birth. What is age? Age is nothing but current date minus date of birth. Now which shape are you going to put inside? Put it inside. It is going to be rectangular shape. Why rectangular shape? Because this is the computation what is going to happen. So age is equal to current date minus date of birth. Next, once you do this, you will get the age. Now you ask the question. What is the question? Is age greater than 18? Is age greater than 18? There can be only two answers, either yes or no. If the answer is yes, what is the output? Output is access is granted. If the answer is no, what is the output? Access is denied. So if the age is plus 18, access is granted. If the age is less than 18, access is denied. So can you say this and end the flowchart? No, you need to stop it. So both the outputs you connect it and you will bring them to stop. So this is how flowchart looks like. So we have discussed four shapes: oval shape for start and stop. We have discussed rectangular shape for assigning a value and for computation purpose. Parallelogram for inputs and outputs. Now the next one is the diamond shape for decision making process. So this is the simplest flowchart discussion what we had till now. Henceforth we will be taking up the sums in your study material. Also we will be discussing the sums which have been given in your past examination, and we are going to solve each and everything. So now let us look at one of the examination problems. That is, draw a flowchart to find sum of first 5 odd numbers. So what is the question? You need to draw a flowchart to find the sum of first 5 odd numbers. So what is the first thing you are going to do? You are going to think, what are the 5 odd numbers? So let us say you will write down what are the first 5 odd numbers. You will say 1, 3, 5, 7 and 9. So these are the first 5 odd numbers. Now you need to total this. You will say this is simple. You will take a calculator and what are you going to do? You will write 1 plus 3 plus 5 plus 7 plus 9. You will get your answer. But I want it in the form of flowchart. So I am not interested in the answer. I am interested in your thought process. How are you going to make this calculation in computer, or how are you going to make computer understand what you want? Correct? So to do this, you need to draw a flowchart. So let us, before getting into flowchart, let us try solving it here. So you have taken first 5 odd numbers, that is 1, 3, 5, 7, 9. Now you need to total it. I don't want one grand total. Every step I want the total. For example, even in your calculator, whenever you are doing, you will do 1 plus 3, you press is equal to, you will get one total. Then you will do, so when you do 1 plus 3, you get a total 4. Then you do 4 plus 5, you get an answer called as 9. Then you do 9 plus the next odd number. So I also want this cumulative total, not a grand total. So when I am doing the first step, what is the odd number? That is 1. What is the total? There cannot be a total. Total is also 1. So I will call total as sum. So when n is equal to 1, when the number is 1, the total or the sum is 1. What is the next number? N is 3. So when n becomes 3, what is the sum? Sum is 4. Sum becomes 4. How did I get 4? I got 4 by way of adding previous sum and the next number. What was the previous sum? Previous sum was 1. And what is the next number? Next number was 3. So I did 1 plus 3 and I got 4. Now the next third step. What is the third step? That is 4 plus next odd number. What is the next odd number? That is 5. So 4 plus 5, I will get the next sum. So can I say that new sum is nothing but old sum plus next odd number? I repeat the line again because this is the crucial logic in this sum. New sum is nothing but old sum plus next odd number. It is simple like cricket score. Let us say the cricket score is 200 and one batsman hit 6. So what is the new score? New score is nothing but old score plus run. So if I have to write it, I will write new score is equal to old score. What is old score? 200 plus run. What is the run? 6. So now what is the new score? New score is nothing but 206. Correct. Same way in here also, new sum is equal to old sum plus next number. So if I want to make this formula still more smaller, rather than calling it as old sum, new sum, I will simply say sum is equal to sum plus n. Now you shouldn't be confused. How sum can be sum plus n? Remember we said what is variable? Variable means the value can change. So 5 minutes back the total of sum was different, the value of sum was different. After 5 minutes the value of sum is different. It is still possible. We discussed when we are discussing variables. So if I have to write it in a formula, how am I going to write it? I will write sum is equal to sum plus n. So this totaling I will do till what extent? Till I reach the last odd number. Which is the last odd number? Last odd number is 9. So I started with 1. I went till 9. The moment I reached 9, I am stopping my calculation. So I need to draw a flowchart for this. How am I going to start? The step number 1, I am going to draw an oval and I am going to put start. So what is the step number 2? I am going to assign values. I am going to assign values. So when I am assigning value, which is the shape I am going to use? I am going to use a shape called as rectangle. So I am going to use rectangular shape and I am going to call n is equal to 1. So what is this n? N is nothing but the first odd number. So I have to tell the system what is the first odd number. So n is equal to 1. Then I need to tell the system to do the calculation. What is the calculation? Calculation is nothing but sum is equal to sum plus n. Or if you really want to understand it, then you have to write down the new sum is equal to old sum plus next odd number. If I want to write it in a shorter form, how am I going to write it as? I am going to write it as sum is equal to sum plus n. Correct? So now will this process run for infinity? No, I have to stop at some point of time. So when am I going to stop? I am going to stop when n becomes greater than 9. So when my odd number becomes greater than 9, then I need to stop it. So I need to do this calculation only till n becomes 9. So the moment it exceeds 9, I need to stop it. But now the question is, how can this n become 9? We defined n is equal to 1. So how am I going to define the next odd number? So as a human, I know after 1 the next odd number is 3, but how will computer know what is the next odd number? So I will assign a formula and I will say the next odd number is equal to previous odd number plus 2. Whenever you add 2 to any odd number, you will get the next odd number. So rather than making it this lengthy formula, that is next odd number is equal to previous odd number plus 2, can I say that n is equal to n plus 2? Can I say n is equal to n plus 2? So I'll again reshape this entire flowchart. So beginning, how did you start? You said start. After starting, you assigned value for n. You said n is equal to 1. Then you did the calculation part. You said sum is equal to sum plus n. Next, what are you supposed to do? You are supposed to ask, is n is greater than 9? If n is greater than 9, you stop it. But what if n is not greater than 9? Then, if it is not greater than 9, you are going to add 2 to n to go to the next odd number. You will add 2 to n and you will go to the next odd number. So let us see how this calculation work in the form of this flowchart. So when you started, n was 1 and sum was 0 when you actually started. But when you came to this sum said sum is equal to sum plus n. So sum became 1. Next, diamond shape, you ask a decision making question, is n is greater than 9? Is n greater than 9? No. As of now, n is nothing but 1. So what will you do? If the answer is false, you will do n is equal to n plus 2. So when you do n plus 2, what will happen? The value of n will change. Now the value of n is equal to 3. You go back and form a loop. And now you do the sum again. So what was the old sum? Old sum was 1. And what is the n now? N is 3. So what is the new sum? New sum is equal to old sum plus the next odd number, that is sum is equal to sum plus n. So sum becomes 1 plus 3. So you get the sum as 4. So do you stop now? No. You go to the next question. You ask again, is n is equal to greater than 9? What is n now? N is 3. So if n is 3, what are you going to do? N is equal to n plus 2. So n becomes 3 plus 2, that is 5. You come back in the loop and do the calculation again. Sum is equal to sum plus n. So what is the sum now? Sum is 4. So sum plus n. So what is n? N is 5. So sum becomes sum plus n, that is 4 plus 5. So what is the new sum? New sum is 9. So again you ask the same question, is n is greater than 9? N is as of now how much? It is 5. So 5 is not greater than 9. So you again go back and add 2 to the n. So n is equal to n plus 2. So n becomes 7. Come back, you do. Sum is equal to sum plus n. So what is the old sum? Old sum was 9. And what is the n? N is 7. So what is the new sum? New sum becomes 16. So now again you ask, what is the n now? N is 7. You ask whether 7 is greater than 9. Answer is no. Go back. You add 2 to 7. So n becomes 9. So you come back and do sum is equal to sum plus n. So what is the old sum? Old sum is 16. And what is the n now? N is 9. So what is the new sum? New sum is 16 plus 9. So you get sum as 25. So again you ask a decision, is n is equal to 9? So you ask, is n is equal to 9, not whether 9 is greater than 9, you ask whether n is equal to 9. Answer is yes now. Answer is yes. So once it is yes, you will not go back and do n is equal to n plus 2. What are you going to do? You are going to stop it. But if you directly stop it, will you get an answer? You will not get an answer. So if you want answer, what are you going to ask computer? You are going to ask computer, or you are going to ask your flowchart, print n, give me an output. You are going to ask print. Are you going to ask print n? No, you are not interested in n. You are going to ask print sum. So in which shape should this print be? It should be in parallelogram. Decision, in which shape it is? It is in diamond shape. Why it is in diamond shape? Because you are making a decision here. Answer could be yes or no. So this is an example of how flowchart will function. So they may ask in an examination hall, find sum of first 5 odd numbers. They may change as find sum of first 10 odd numbers, or they may ask find sum of first 100 odd numbers. So they may keep on changing the numbers, but your flowchart will not vary. The only thing that will change is your decision. Here, whenever I am asking find the sum of first 5 odd numbers, I am saying whether n is equal to 9. Whether n is equal to 9, the moment n becomes 9, I am going to stop the loop. But if they are asking find the sum of first 10 odd numbers, what are you going to do? You have to think what is the last odd number. What is the last odd number in the first 10 odd numbers? So it is 19. Alright. So if I make a list of first 10 odd numbers, what is the 10th odd number? It is 19. So instead of 9, I am going to replace it with 19. So in the examination, if they ask you find the sum of first 100 odd numbers, the logic is same, the flowchart is same, only your decision will change, computation will not change. So instead of asking is n is 9, you are going to ask, if they ask in examination hall, find sum of first 100 odd numbers. What is the 100th odd number? Now you need to think the 100th odd number is 199. It is 199. So what is your decision? Decision is n is equal to 199. Answer is yes. Then your loop should stop. So this is how you should think when they give you mathematical computation. Now let us look at one more examination question, very simple examination question. Here what they have done is they have given an algorithm to you and they want you to draw a flowchart on that algorithm. Now let us have a look at what is that algorithm. They are saying step 1, or they are calling it as L1, n is equal to 1, L2 print n, L3 n is equal to n into n plus 1, L4 stop when n exceeds 100, L5 go to L2. So this is the algorithm what they have given. Let us do it in the form of flowchart. Very simple. So how do I always start? I start with start in my oval shape. Now what is the next thing they are asking me to do? They are asking me to define, assign a value. They are asking me to say n is equal to 1. Now you tell me if I have to assign a value, which shape I am going to use? I am going to use a rectangular box. So start, then in a rectangular box n is equal to 1. Till now very simple. What is the next step? They are asking print n, that is they are saying print n. So if you have to print something, what shape are you going to use? You are supposed to use parallelogram. So you are using parallelogram shape and you are going to write print n inside that parallelogram. Next thing is they are talking about a computation. So what is the computation they are talking about? They are saying n is equal to n into n plus 1. N is equal to n into n plus 1. Correct? So if you want to make this computation, in which shape you are going to put? If the computation you have to do, which shape it is? It is rectangular shape. So in a rectangular box you are going to write n is equal to n into n plus 1. Next they are asking stop when you reach 100. When n becomes 100 you have to stop it, or when n is greater than 100 you stop it. That is what exactly they are asking. When n is exceeding 100, when n is greater than 100 you are supposed to stop. Now this is the case where you have to make a decision whether n is greater than 100 or lesser than 100. If it is greater than 100 they ask you to stop. If it is not greater than 100 you have to go back and you have to perform your calculation again. So this is how your flowchart will look like. So if n is not greater than 100, what are you going to do? You are going to form a loop. So whenever I am saying loop or iteration, you are doing the same thing again, the computation again, you are redoing the computation. So if n is not greater than 100, then you have to run the formula again, that is n is equal to n into n plus 1. So we have drawn this particular flowchart. Now let us run this flowchart and see what is the answer that we are going to get, because that is also the question. So this is an 8-mark question. For the first 4 marks, they are asking you to draw the flowchart. So we have the flowchart ready with us. So what is the second question? That is for 2 marks. They are asking list the output from the above program. So what is the output that you are going to get? Now let us start. First you have defined n is equal to 1. You have defined n is equal to 1, and next print n. So print means you have to give the output. So what is the first output? You will print first output is 1. Next what are you going to do? N is equal to n into n plus 1, that is n is equal to 1 into 1 plus 1. 1 into 1 plus 1, that is nothing but 1 into 2. So what is n now? N becomes 1 into 2, that is nothing but 2. So you ask the next question, is n greater than 100? Answer is no. If it is no, what are you going to do? You are going to go back to print step. You are going to print n. So what is n now? N is 2. So already you have printed 1. Now you will again print 2. So first output is 1, next output is 2. So you will do the computation again. What is the computation? Computation says n is equal to n into n plus 1. So what is the computation? N is equal to 2 into 2 plus 1. 2 into 2 plus 1, nothing but 2 into 3. So what is n? N becomes 6. Ask a question again in a diamond shape. Is 6 greater than 100? Answer is no. What are you supposed to do? Go to print n. So we already have 1 as the output, we already have 2 as the output. Now again one more output we are getting. What is that output? That is 6. Correct? So we have 1, 2, 6 as output. Now we are going to ask is, okay, so we have a n called as 6. Now we are supposed to do the calculation again. N is equal to n into n plus 1, that is nothing but n is equal to 6 into 6 plus 1, that is 6 into 7. So that becomes n is equal to 42. So you ask the next question, is 42 greater than 100? Answer is no. What are you supposed to do? Loop, go back, print n. So now what is n? 6 into 7, we got n as 42. So as of now we have output 1, 2, 6, one more output. What is this? 42. So we got 42. Now what are we going to do? We have to again run the formula, that is 42 into 42 plus 1, that is 43. So n is equal to 42 into 43. What is the answer what we are going to get? So it is 1806. So is it greater than 100? Definitely it is. So are you going to go back and print n? No. The moment it exceeds 100, you are supposed to stop. So now what is the output? 1, 2, 6 and 42. So if you write this, you will get 2 more extra marks. For drawing this flowchart, 4 marks. For writing the outputs, that is again 2 marks. So what examiner wants is to understand that whether you can understand the logic. So there is one more question for 2 more marks. What is the question? They are saying, list the output if the above program is modified in step L1 as n is equal to 0. They are saying, if n is 0, initially we initialize the value called as n is equal to 1. Instead of writing n is equal to 1, if we write n is equal to 0, what is going to be the output? Now before I answer, I want you to think for 15 seconds at least. Pause the video, think for 15 seconds. What is going to be the answer? Now let us see the answer. Answer is, you started it and you defined n is equal to 0. Now you are supposed to print n, correct? You are supposed to print n. So what are you going to print? Nothing. N is equal to 0. Next step, n is equal to n into n plus 1. N is equal to n into n plus 1. So what is n? 0. So 0 into 1, what is the answer? Again answer is 0. Again answer is 0, and you will ask whether 0 is greater than 100. Answer is no. You go back again. No matter how many times you go back, answer will always be 0. So this program will never end. This program will never end. So we will never get an output. Because output is only possible when your program has come to an end. So this is an infinite loop. So there is no output that what you are going to get. So in an examination, you are supposed to write if n becomes 0, then it will form an infinite loop and there cannot be any answer. So if you do this, you will get 8 out of 8. So flowchart is one of the most simplest thing in your entire syllabus where you can get full marks if you understand the logic.